It takes a cast of hundreds of people every year to make TechFest happen, between our researchers and our program managers and all the support staff. It's really an event that the entire division as a whole gets involved in and gets behind.
When we first started TechFest, I actually wondered whether we would even get very many employees to come. The first year I was just flabbergasted. So many people showed up.
TechFest is important for Microsoft Research because it's a jumping off point for great conversations. Each year we get about 300 technology demo proposals submitted. From there, we spend the next couple of months looking at what's happening across all of our different labs to really find the best of the best. And in the end, we pick about 150 of them to bring to Redmond and to put into a show floor.
The importance of doing state-of-the-art research is vital for the continued health of the company. Sometimes the impact is immediate, and sometimes the impact is over the long term.
I always get excited when I go around to the different booths. I get a chance to see the research projects, and there's always something that surprises me. There's always something new that I didn't even know we were working on.
We treat technology transfer much more as a social process than as a logistical and mechanical and process-based one. In the end, we try to balance out really amazing technology, but also really looking for what are the things that will change people's mind? What are things that people just simply couldn't imagine it's possible to do, and now it's possible to do?
It's really valuable for us to be able to have our researchers interact with our employees, to really give them a sense of what we're doing, but also to learn from the employees or what's important, what are they working on.
Ladies and gentlemen, please welcome Senior Vice President, Microsoft Research, Rashid.
You know, I always think it's fun having the big voice and the loudspeakers announcing you coming on stage. I can remember back when I was a professor at Carnegie Mellon University during the 1980s. I don't think I ever had a big booming voice welcome me on stage. It's not quite like being a rock star, but it makes you feel a little bit better. So I want to welcome you all to TechFest. This is, let's see, probably like our 10th now. We started TechFest in 2001. And I want to sort of set the stage for you a little bit. Obviously, most of the fun of the day is going to be going around looking at the various technology demos and having a chance to talk with the researchers. But I wanted to set the stage a little bit and talk about sort of who we are and why we do what we do. Why is basic research an important thing for us and for Microsoft? Now, when you think about doing sort of fundamental basic research, which is what we're engaged in, there are a number of values that you can derive from it. Clearly, we think that investment in basic research is essential for survival of our industry, of the technology industry. I mean, we're built on investments in research. We're built on R&D. But I think it's also increasingly the case that computer science isn't just impacting the technology field in the traditional sense of the word, but in fact, we're also increasingly impacting many areas of science and technology. And you'll see more about that during the course of today as you see some of the demonstrations that we're doing. And I'll talk a little bit more about that in a bit. And then even stepping beyond that, I think the field has a lot to offer in terms of addressing some of the key societal problems that we have. And I'll talk a bit more about that. Well, how do we all get started? In 1990, there was a memo that was actually written to the board of directors at Microsoft by Nathan Myhrvold. And Nathan argued that it would be important for Microsoft, which, by the way, was a very small company back in 1990, to engage in long-term basic research. And despite the fact that the company just crossed $1 billion in sales, now it's over $60 billion, just to put it in perspective. A relatively small number of products, but Nathan, argued strongly that it was important for the company to think long term and to think about the future, and so it was really an act or an agreement by the board of directors that really started the process of creating Microsoft Research. I came into Microsoft in 1991, so I was recruited over the spring and summer of 1991. I said no a lot, and so I think Nathan internally referred to me as Dr. No for quite a while. But he was very persistent, and I finally agreed to come to Microsoft to start Microsoft Research in September of 1991. And before that, I'd been involved in doing a lot of different kinds of projects, operating systems projects such as the Mac operating system, which is today the basis for the Mac OS X operating system and the iPhone operating system. I developed some of the early network computer games like AltoTrack, developed a number of key technologies and technologies ideas such as NUMA or non-uniform memory access architectures and things of that sort. So that was my background. And really, when I came to Microsoft, I wanted to build a strong basic research organization around three fundamental concepts. And this right here is the oldest slide in my deck. People always say you should measure your decks by how old your slides are. Well, this one is 18 years old. I've been using this slide for 18 years, and that's because we've had exactly the same mission statement, for the entire history of the organization. I don't know if that sets a record or not. The first part of our mission is really expand the state of the art. I mean, we're about moving knowledge forward, moving the state of the art forward in the areas that we do basic research. And an important part of that statement is the fact that there's not the word Microsoft in it, right? This is about being true to the individual areas of research that we do and moving the state of the art forward. It's not about saying, well, we're going to work on something just because it's interesting to Microsoft. And I think that's particularly important because unless we're moving the state of the art forward, in the areas that we're working, I don't really think we're ultimately going to be that valuable to Microsoft or anybody else. So we think it's important that that be the first part of our mission. Now, when we have great ideas, then the second part of that mission statement comes to play, which is, if you've got an idea that makes sense, we work really hard to get those ideas into our products. And over the course of the history of Microsoft Research, you saw that in the video earlier, virtually every Microsoft product that we have today has in fact been impacted by the research that we do. Either that there's technologies from our research organization in the product, or the product itself comes directly out of our research, or the technologies used to create the product came out of our research group. Ultimately, all this is about making sure that Microsoft and the technology industry and the field and ultimately the society really has a future. I mean, that's why we invest in basic research. We've grown quite a bit over the years. From I think that 1991, that's one. That was me. And now we're about 850 PhD researchers spread around 6 research labs around the world. And to put that in perspective, that's sort of roughly the equivalent of having created a Berkeley computer science department size faculty every year for every year that Microsoft Research has been in existence. So that gives you a sense of about how we've grown and what we've been able to do over that period of time. Here is kind of a sense of sort of how we're distributed around. The named entities here are specific groups, either research groups. There are 6 research groups: Redmond, Silicon Valley, New England, Cambridge, India, and Asia. Then we also have some technology centers in Cairo and Aachen, Germany. But we're also very much involved in doing collaborative research with other organizations. We have joint technology centers, labs, cooperative organizations that we work with around the world. We have, for example, a center for computational and systems biology in Trento, Italy that we work with. We have a center for high-performance computing and large-scale multiprocessing in Barcelona that we work with. There's a joint research center with INRIA, the French IT research organization, in Saclay near Paris. So if you look out around the world, it's not just our footprint as a single organization that you'll see, but you'll see us engaged with many other organizations around the world. In Latin America, we have something called the Virtual Institute, where we collaborate with researchers in a number of top Latin American universities and bring them together to do research. Now, when I came to Microsoft, my idea of how to do basic research was very much built on the way I'd been doing basic research when I was at Carnegie Mellon. And so in some sense, the way we're organized for innovation was the way Carnegie Mellon University's computer science department was organized for innovation back in the 1980s. That was my model. That's the approach I've taken. I've continued to use that approach all the way through. It's been an important part of what we do that we're open in our research. We publish our research. If you go out on our research.microsoft.com website, you can find out who works for us. You can find out what they're working on. In many cases, you can download their papers. You can download demos. You can download code in many cases as well. So we've been very aggressive about getting our ideas out to that academic community in the form of peer-reviewed publications. We bring a huge number of visitors. I don't even know the number. It's very, very large into the organization each year. At any given point in time, there are dozens of visitors from other universities, from other research organizations or government agencies. We bring an enormous number of interns in, and we run basically, certainly the largest PhD internship program that I'm familiar with in the technology field. It may even be the largest in the world. We have over 1,000 PhD interns working in a Microsoft Research Lab, at some point during the year. Just in Redmond, last summer, we had over 350 PhD interns. And to put that in perspective, the United States produces about 1,800 PhDs a year in the field of computer science. So over the course of their careers, a large fraction of all PhD students in the United States will likely work at some part of Microsoft Research. So there's a lot of interaction. In some sense, there's as I did the calculation once, I believe we have more graduate student hours in graduate students working at Microsoft Research than any university has in the world. So in some sense, we have both a very large faculty and a large number of students that work with us. I mentioned that one of our key goals was moving the state of the art forward. And while we don't measure ourselves by the number of papers, but rather by the quality of the work that we do, I wanted to put this up just to give you a sense of what the level of impact is on many of the major conferences today. I think we're either the number one or one of the top publishing institutions in the field of computer science. And in many top conferences, you'll find anywhere between 15 to 30% of the papers will come from someone at Microsoft Research. So there's a huge impact there. Now, there are lots of reasons, why you might think about doing, basic research. For me, the key value, the key reason that I believe Microsoft invests in long-term basic research is this top point, which is it gives Microsoft agility. It gives Microsoft the ability to change when change is important. Research provides a reservoir of technology and ideas and expertise so that if you have a new competitor, if you have a change in technology or a change in the business climate, if Microsoft needs suddenly to react and change or enter a new business, the chances are good that within Microsoft Research, we will already have been working in that area. We will already have some of the best people in the world in that area, and we'll be able to help the company enter that new space and to help lead it in a new area. Whether that is things like getting into the game console business, in 1999, 2000, whether that's in entering the large-scale internet search business, with our search technologies and Bing, whether it's getting involved in, historically in things like, streaming media and things of that sort. So yes, in most of the traditional measures of value that people often assign to basic research, Microsoft Research, helps the company do that. Probably a quarter or more of our patents come out of our research organization. And that's certainly valuable to the company. In fact, Business Week had an article a few weeks ago where it said that it rated Microsoft's patent portfolio as the most valuable patent portfolio in the technology industry. And I think IEEE's had published a study a couple years ago saying that we had the highest scientific value of any patent portfolio in the technology industry. So clearly that's a value to Microsoft. But I would argue that's not why we do it. It's a value. It's a consequence of having a great research group. Problem solving. People often say, well, you should have a research group so you can do problem solving. You can solve the corporation's problems when they have them. Well, that's great, and we love solving problems. I mean, I personally love solving problems. I love it when somebody comes to me, they've got some hard problem, I can noodle on that, think about it, figure out a solution. That's great. I really enjoy that, and most of our researchers enjoy doing that too. But that's a consequence of having a great research organization. It's not really why you do it. Early warning system. Again, people often say you should have a research group because it's a great early warning system. And it can be, although sometimes the warnings aren't always heeded. You might say, hey, this internet search thing might be big someday. You can say that, right? And people might or might not listen to you. But the point is, these are all values that a basic research organization brings. And Microsoft participates in all these values. I mean, these are all great. Everybody's super excited about what they get from the research organization. But at the end of the day, this isn't why you do basic research. You do basic research for the point I made before, which is you do it to survive. You do it so that if something awful happens, or if there's some big change, you can react to it. Now, we do drive a lot of technologies into our products. And that is an important part. Remember, that was the second part of our mission statement. We do that, and it's an important part of what we try to accomplish. And if you go through, there's so many things. I was involved in starting the group that eventually became the digital media division of the company. Started that as a research group in 1992. We built it up into a product team and spun it out in '96. I ran the DirectX team in the early days, because of a lot of the 3D technologies we developed in research were becoming important in our Windows environment. I started the first e-commerce group in the company. All of the key data mining technologies that went into SQL 2000 came out of a collaboration between the research organization and our product teams. You can look today at things like the Xbox or Bing or many of the products that Microsoft does, and many of them came historically from collaborations with the research organization. You're not expected to really read through this list. This is just the short list of sort of key things that went into Windows 7, Office 2010, and some of our other recent releases. Now, I mentioned that that ultimately this isn't just about Microsoft, but it's also about solving key problems. And if you look at the research that we're doing, increasingly you'll see that we're not just impacting sort of near-term Microsoft technologies or even computer science technologies, but increasingly working in areas such as healthcare, environment, energy, and education. So in the healthcare, for example, we're one of the key players in the search for a vaccine for AIDS. We've been developing a lot of the technology that's used within the AIDS community today, and we've been developing, coming up with new ways of looking at the way the immune system reacts to the AIDS virus and how we can address that in the development of new vaccines and new treatments. Similarly, we've been looking at other diseases, AIDS, malaria, hepatitis C. More recently, we've just published a paper in Science just a couple weeks ago, some work that we've been doing in the area of looking at asthma and some of the causes for childhood asthma. So increasingly, computer science technologies and the ideas from the field, the theory of computer science, are having an impact in biology and medicine and healthcare. Similarly, environment, as we start to think about building much larger scale models and sensing more information, again, I think the field of computer science can make a big difference there. And for example, we have a large scale project looking at the water quality in the Russian River Valley in California and the watershed and collecting lots of sense data, collecting that information, and then disseminating it to scientists. Energy, education is another area where we've been developing a number of key educational technologies to try to be able to get young people more excited about engineering, more excited about learning, programming, learning technology, and some of those, some of the technologies, in fact, already in use in schools around the world. So with that, I'm going to give you, so I'm going to stop talking now and let you get a glimpse of some of the things that you're going to be able to see later today. And I want to introduce Desni Tan and Dan Morris, who are going to show you what I think is a pretty fun research project looking at new forms of user interface. Desni or Dan?
Awesome. Can I steal your clicker, Rick? Awesome. Thanks, Rick. So Desni and I are going to be showing you some real cool new technology we're working on in the area of mobile natural user interfaces. So you're going to hear a lot this week about natural user interfaces. You've probably heard of that before. Systems that make communicating with computers more intuitive, more like the way we interact with the rest of the world that isn't computers. This is an area where Microsoft has already made a lot of progress. You've heard about Microsoft Surface. You've heard about Microsoft Multimodal. These are both systems that make interacting with different types of computers more natural. The question we're really interested in is, what do natural user interfaces look like on the go? What's a mobile natural user interface? And the specific approach we're taking in our research is to look at on-body interfaces, meaning if we can turn your body into the user interface, you have an interface that goes with you everywhere. So we're looking at what sensing technologies can we use to build on-body interfaces that are natural and always available. I'm going to show you two technologies that we're working on in this space. The first of these two we call muscle-computer interfaces. So it turns out your brain uses electrical signals to communicate with your muscles. When you want to move your arm, your brain sends an electrical impulse down your spinal cord, down your arm. And we can actually look at that electrical activity with sensors on your arm. So our vision is, imagine you could put on a slick little armband like this that had electrical sensors in it, looked at the activity that was going on in your arm, and figured out what your hands and fingers were doing. Then you could have an interface that went with you everywhere, so you could communicate with a computer, with a display on the wall, with your cell phone. And you can imagine this having a wireless link to a nearby computer or to your cell phone in your pocket. Now, that's our vision. We're not quite there yet, but we're a lot farther along than where we started. Where we started was clinical muscle sensing technology. This is a technology that's used for rehabilitation and for a variety of other medical purposes. It looks something like this. Typically in a clinic where this is used, you have these electrodes that are kind of glued to your arm and have these big cables on them and cost a ton of money. So we've come a long way from there. Where we are now is we've built a prototype of a wireless muscle sensing unit that can sense and decode finger gestures. And so now I'm going to turn things over to Desni for a quick demo of what this looks like.
Thanks, Dan. So hopefully you guys can see me, because I've got a couple of these stylish armbands on me. These are actually hot off the presses, so these are the only two that we have, so you'll see me treating them fairly carefully. If you look up at screen, what we have here is sort of a backstage view of the data. You'll see sort of data streaming across. That's the signal that's coming right off the electrical muscle activity on my arms. If you see me pinch my finger, so I'm going to pinch my middle finger down on the lower left, you'll see the computers start to recognize my finger gestures based on the electrical activity. Now, I've mapped my right hand to a strumming gesture, that's the upper right. And in case you don't already know where we're going with this, let's go ahead and swap to the game. Let me see. Looks like my Xbox doesn't want to play today.
It's not research if it's not high risk, right? That's what you guys come here for, right?
Well, we're going to be showing this in the booth. Let's go ahead and swap to video.
Awesome.
So swing by our booth later, and I'll show you this thing running live. The Xbox just crashed. So could I get the slides, please? So obviously, Guitar Hero isn't the be-all, end-all app, and we're exploring other mobile scenarios as well. Computing on the go, controlling your music player as you run. Maybe your hands are busy and you want to type your email. All things we can do with these sensors. Here's one that we sort of coupled to a different technology because we also don't project that this is going to be the only technology, input technology that we have out there. In fact, we've coupled this particular one to the Microsoft Surface. So in the upper left, you'll see the armband sensing which finger is touching the surface in order to change the commands on the surface. In this case, simply changing the color that you're drawing with. So the muscle sensors are sensing which finger is touching the surface, and the surface is sensing where on the surface you're touching. On the bottom left, you see a slightly different version of this. So user there starts the gesture on the surface, but because we're on the body and because we can continuously sense your gestures, user is able to pick up the objects off the surface, change the canvas, and then throw it back onto the surface. So we really grow the interaction space around the Surface device. So let's move into a second technology that we're going to show today. In this case, using bio-acoustics rather than electrical activity to turn the arm into an input surface. So this was work done with Chris Harrison, who's actually out here in the crowd today. One of our recently awarded 20 graduate fellowship students, and congratulations to all the students out there who have just received this award. So here's what we're going to do. We're going to try to turn the arm into a tap surface, much like that. Now, if we slow it down, it's a little bit disturbing, but you'll see the mechanical energy propagating through the arm, even with fairly gentle taps. So it turns out that the arm is not uniform, and so based on the energy patterns that we see at various points in the arm, we can actually determine where on the arm you're tapping. This is a device that Dan's got on right now. It's got a couple of vibration sensors, in fact, 2 arrays of 5 vibration sensors, each fairly well tuned to a specific range of frequencies. So actually, let's go ahead and look at the signal. Dan's got the device on right now.